May 2014, paper 3, problem 3. We're given a power series, and the first thing we want to do is to express it in a different form. They want you to figure out what you're multiplying together in the denominator to get those terms: 1 times 2, 4 times 5, 7 times 8, and so on. So the first part of this problem is find the functions b of n and c of n. In other words, you want to write each of these products as the product of two linear functions. It tells us they're linear functions. Well, that's not too challenging, really. But let's take a look at this power series. Notice the numerators are all x to a power. The first term is x to the 0, and the next term is x to the first, x to the second, and so on. So let's write this in sigma notation, which we'll use later. So n is going from 0 to infinity, and the power on the x is n. So it starts at 0, x to the 0. Now the denominator is the product of two functions, and that's our first goal, is to figure out what those two functions are, linear functions. Well, if you take a look at those numbers, what I'm going to do is set up a little table for the n value, the term value, and the value, well, they're calling it b of n, so let me label it as b of n. So a little table, 0, 1, 2, 3. Since they gave us the first three terms of the power series, notice the first numbers are 1, 4, 7, and 10. Well, since it's linear and n is 0, you get 1. That means that's the y-intercept. Think linear is y equals mx plus b. So b is 1 when x is 0. And then the slope is the change, which is constant 3. So it's 3x plus 1. So therefore b of n, we're going to write as 3n plus 1. Likewise, to find c of n, same thing. We'll look at the term number, starting at term 0, 1, 2, 3. And the numbers go 2, 5, 8, 11. Again, there's your y-intercept, plus 2. And the slope, again, is increasing by 3 each time. So it's 3x plus 2 as a linear equation. So they want us to write it in terms of c of n. So c of n equals 3x plus 2, or 3n plus 2, rather. And there you go. Part A is done. So let's, before we find the radius of convergence, let's write this power series totally in sigma notation. N equals 0 to infinity, and the numerator is x to the n. Of course, those ones, we don't need those. And the denominator is going to be b of n, which we just found out, 3n plus 1, times c of n, which is 3n plus 2. Okay, now, part B, find the radius of convergence. Well, remember the ratio test. Let me get some of this stuff out of here. The ratio test, we're going to take the limit as n goes to infinity of the absolute value of the next term, which would be x to the n plus 1 over the next term. So we increase all our n's by 1, so it's going to be 3 n plus 1 times 3 n plus 1 plus 2. So it's the next term compared to the ratio of the previous term, which is the original term. So we're putting that on the bottom. In other words, we're going to reciprocate that. So I'm going to put 3n plus 1 times 3n plus 2 over x to the n. Now the ratio test says that will converge when that ratio is less than 1. So all we have to do is clean this up and figure out what values are going to make that less than 1, what values of x. So let's clean up this mess. Well, let's separate our x's. We'll go x to the n plus 1 over x to the n, and we'll separate that from our n's. Now I'm not going to multiply all this out, and you'll see why. You could FOIL all this if you so desired, I guess. But what you're going to notice here in a second is you're going to be able to take this limit just by observing the power of the numerator and denominator. And that has to be less than 1 still. So x to the n plus 1 over x to the n is simply x. That's taken care of. Now, the second part, n is approaching infinity. Well, what you're going to get in the numerator, you're going to get a 9n squared plus some other terms. On the denominator, you're going to get 9n squared plus some other terms. So as n goes to infinity, what's going to happen, you can look at the coefficients of the highest power if you want to use that trick, or take and divide through by the highest power, n squared. You're going to end up with 9 over 9, or just 1. So all this boils down to 1 as you take the limit. So the limit as n goes to infinity is simply the absolute value of x. And that has to be less than 1. So since the absolute value of x has to be less than 1, that means x must be less than 1 and greater than negative 1. So from this, we can figure out what the radius of convergence is. The radius, remember, if it's halfway between negative 1. Oh, my microphone freaked out on me there for a second. So as I was saying, the radius of convergence is halfway between the two endpoints of the interval. So from negative 1 to positive 1 is the length of 2, so the radius of convergence is 1. So radius of convergence equals 1. So part B is done. That was 4 marks. Now part C is the interval of convergence. Well, you would think, well, we've got it, don't we? It's from negative 1 to 1. Well, you have to check the endpoints. So we have to remember, you have to pull some tests out of your hat to check those endpoints. So we're going to go back to our sigma notation, which is from 0 to infinity of x to the n over 3n plus 1 times 3n plus 2. And we'll think about this. If x equals negative 1, what happens to this series? Well, if x is negative 1, then it's going to alternate. And also, as you go to infinity, the denominator keeps getting bigger and bigger and bigger, so the terms keep getting smaller and smaller and smaller. So if x equals negative 1, that endpoint, it is going to converges by, I'll just abbreviate, the alternating series test. Okay, now let's take a look at if x equals 1. If x equals 1, the numerator is always going to equal 1, so you're going to have 1 over, again, 9n squared plus some more. And you can compare this to a power series. Remember, a power series will converge if the power on the bottom is 2 or greater. So therefore, it also converges. The pen doesn't want to write. There we go. Converges by p-series test. So both endpoints will cause convergence. So the interval of convergence, the last part of this question, the interval of convergence is from negative 1 to 1, inclusive on both ends. And that is the end of problem number 3.